in ways that you can't otherwise. This is one of the key things. It can make your code a lot more concise. Use DSLs freely. And then, of course, the most obvious one, test thoroughly. Okay? Even if you have derived your program from semantics, and you've derived your deriver from semantics, and you've derived the driver of the driver from semantics, you still need to test. Everything needs to be tested. And when you test, you need to test all the edge conditions. You need to test other inputs that aren't edge conditions. You need to ideally have somebody who doesn't know the code, the implementation, write some tests. And somebody who does know the code, write some tests. Every time you modify the code, you need to add new tests because you may have introduced new edge conditions in the implementation of the code. Say because you want to have one algorithm for inputs up to size million and another algorithm for over a million, you need to test that edge condition. Benchmark. You want to know how fast your system runs? Benchmark. And you want to know if it got slower from the last release, or if you got an improvement that you were hoping for. You need to benchmark. You need to do it in a scientific way. You need to actually do the standard deviation or some other technique to determine if you've actually got a meaningful result when you do the benchmark. And I don't mean you should benchmark it against other systems. Some of you have heard my rants about this. I don't think that benchmarking across systems is very useful. There's a lot of characteristics of systems that differ from one to the other. A lot of different purposes that systems use sources of language, bake-offs. Don't thrill me at all. Every time somebody contacts me and says, "Hello, will you help me enter the chase in this bake-off?" I say no. And I give them my rant. And then document. I put this one last, but it is definitely not least. In fact, it's top on my list. I have found more bugs, both in functionality and in performance, writing documentation, writing papers, preparing this talk, great talks, than I have writing tests. Documentation covers, documenting the system covers more bugs than testing, by far, in my experience. Documentation forces you to think about it in a way that you don't think about it when you're writing code, and oftentimes when you're testing code, you're thinking about it the same way you're writing it. You're documenting it, you're trying to describe something that doesn't know anything about what you had in mind. So especially if you're for user documentation, when I write this chasing user's guide, I'll go to the document something and I'll say, well, this is really not a good interface. This is really a bad idea. Wait, it doesn't have a listen case, this condition. So I can't document this. I'll have to go back and fix it. Okay. If I'm writing a paper on this or some other functional document in software, I'm working through all the cases, saying how it works. And I say, wait, I don't think we have that case. Okay. So that's a really important observation that I have. That documentation is the number one most important thing if you want to have good, reliable code. Questions, comments? Okay, so the chase scheme context is a special case, not so different from the RacketCon context. Reliability and efficiency have to apply to various different parts of the system. In particular, it has to apply to the compiler. It has to apply not just the compiler, but the code that it generates. There's a set of scheme code libraries. It has to apply to them. And because the scheme compiler is compiling the scheme code libraries, it has to apply to the code the scheme compiler generates for those compiled libraries. There's some C code in the OS and GC interfaces, and although I didn't add it to my list at the end, if somebody really wants to do a favor for the Shade scheme community, they could rewrite the GC in the scheme. That it's in C. We have no control over the performance of it. It's always I think we can do a better job. And even the code users write. This is a little bit of a funny one. Okay. We want to actually make sure that the code users write and that the users actually have a way to make their code more efficient and more reliable. Not just by the fact that sitting under the programmers efficient and reliable, but actually sort of guide them into reliable things. So you design your language in such a way that they're guided towards writing good code. Right? And you give them tools to debug or give them tools to profile so that they can find out when their code isn't exactly what it should. So a really good example of the great outside of what's been seen development is let. The existence of let in our language pushes people towards towards writing code that isn't imperative. Right? If we didn't have let in our language, just had setbang, setcube, or whatever, people would be writing mutation code that mutates a lot. And although I didn't list mutation as one of the things to avoid, that's something to avoid. It generally is something to avoid. A lot of the bugs that I find have to do with some sort of state change that interferes from one part of the code to another. People ask me, these are your two main objectives, which is more important? And I would say that reliability is fairly out front of efficiency. If we really are pushed and we have to make a choice, we will always go for reliability. We'll never shortcut on having it be correct. Or have a costing crash or anything like that. Okay? But we will we'll fight tooth and nail to make sure that we don't give up any efficiency in making it reliable. Other things we won't do as much. So we might not have as good a debugging support as we could. We may not have as big a feature set as we could. We spend our time on these other things. Or because actually having the debugging support in there makes things slower. Or having the extra features makes other things slower. Okay? Or makes the system fragile and unreliable. But we can figure out how to make this a feature reliable and efficient. We don't have it. Right. Can an effective compiler actually be fast? The answer is yes. In fact, there's some real advantages in having an effective compiler if you want to have a fast compiler. In our case, the compiler is written in Scheme, of course. So every time we make Scheme code run faster, the compiler runs faster, just by the very fact that it's written in Scheme. And the libraries it uses are all written in Scheme. Almost the entire system is written in Scheme. So every time we make Scheme run faster, the whole compiler and everything depends on runs faster. So even if we have to add some new paths to the compiler, and that takes up a certain amount of time, sometimes you don't even notice the amount of time that path takes. Because everything else got enough faster by virtue of that new pass that it now runs faster. Moreover, if you have an optimization that happens fairly early in the compiler and actually cuts down the amount of code generated, all the rest of the passes now run faster because they have less to chew on. We see that a lot. We saw closure optimization. When we started doing a better job with closure optimization, we had a pass for doing closure optimization. It wasn't that simple. It's not particularly expensive pass, but it has some expense. But it made the compiler run significantly faster, even when we compiled the compiler without it. So we compiled the compiler with closure optimization disabled, but we included closure optimization in the compiler, and then we used that compiler to compile other code. That compiler was actually faster because it cut down the size of the generated code, and later passes were faster as a result. So we do have some advantages. It's not as silly as it seems that you have a fast compiler that generates fast code. You have to choose fast optimizations and avoid quadratic behavior, and Matthew stripped over our register allocator a couple of times, 10 times maybe. About 4 or 5 times in pull requests because we were not avoiding quadratic behavior there. And there's a few other places where we don't avoid quadratic behavior that we should. I choose quadratic behavior because it seems to be the line above which things start getting bad much faster. And one of the things that people often don't realize, especially students coming into compiler course when I used to teach that, is that most code is actually written by machines, actually machine generated. And so I'll always get these comments, well, nobody would ever write a program like that. We have to handle programs with 1,000 variables. Nobody would ever write a program like that. Nobody would ever write a program like that, but they would generate a program like that. They say, I don't believe you that most programs are machine generated. I have no answer for it. Bootstrapping. But even in our context, a lot of programs are machine generated. They're generated by macros. They're generated by or partial generators that are generated by transform systems of one sort or another. So, and we prefer more fast optimizations over fewer slower ones. So the idea is to take a shotgun approach to optimization. Rather than have a couple of really killer optimizations, you get 90% out of what you can do 10% of the time, and move on to the next thing. That's the way that you can make sure that your compiler stays fast. Complicating factor with JScheme and with any other optimizing system is that there are actually multiple implementations of different features. I'm focusing on primitives here, but it can be true of other things as well. And that's because you've got a source optimizer that may be doing something to either fully implement or partially implement a primitive. You have the later part of the compiler may be generating open code for that primitive if it survives source optimization. Okay. And then, of course, you got to have a library routine for it in case you call map on the thing. The compiler is not successful at open coding it. And sorry, that's the order definition. And then we also have this thing called library.ss, which is sort of halfway between the full implementation and the part implementation. Often does only part of the job, and probably does the rest. Yeah.
I'm not familiar with open coding.
Open coding means you take instead of calling the function as via function call, you put the code for the function in line. Okay. So this actually puts some strain on the testing protocol, because now you have multiple different implementations. You have to somehow get at and test each one of those implementations. So that means for us, we have to test the different optimization levels. We have to test with our source optimizer disabled and enabled, and test with primitives recognized or not. That gets at this definition right here, and then we vary other parameters for mixing variables. Speaking of tests, JScheme has a sizable test suite. It's about as big as the source code for JScheme in terms of total number of lines. And we have a bunch of just little things testing little features. Test this primitive, test that primitive. Of course, each one of those tests uses other primitives to test it with, other syntactic forms to test it with, so each unit test actually ends up testing several features. Then we have some larger tests, actual testing system. We have some tests that actually say to the compiler, generate this code and tell me what source code will result. And we look at that source code, we compare it with what we're expecting, and make sure that we're actually doing the optimization, the source optimization we want to. It'd be great if we could do this for downstream optimizations. Right? We could say, are you generating the machine code you expect to generate? That's a really tedious thing to do, and almost constantly out of date, too hard to maintain. So I don't have a good way right now, a good idea of a way of making sure that the optimizer is actually doing its job, except for benchmarking. Bootstrapping. For those who don't know what bootstrapping is, it's taking literally it's lifting yourself up on a horse by means of your bootstraps. You reach down and pull your bootstraps up to push yourself on the horse. But in the language context, it means if the system is written, if a system like JScheme, if the compiler is written in Scheme, you actually have to compile the compiler using Scheme. And the process of using the same Scheme system to compile itself is called bootstrapping. And it's nothing magic. Everybody thinks it's this big magic thing. It is difficult. anybody who's tried it. But it's not, there's nothing magical about it. You simply take the last version, use to compile the next version. Then if you want to do a sanity check, use the new version, then we compile the new version and make sure it gets the same code as the old version gave. This is one of the most strenuous tests that you can do on a system because it tests a whole lot of the system. You can't get the system compile itself and be able to test it with compiling itself 2 or 3 times and making sure it gets the same output each time, unless the system's working really well. On the other hand, it tends to test the same set of stuff every time. Right? It doesn't tend to test anything new unless you actually use that feature in the compiler. This is actually something we try to do from time to time. As we add a new feature to the system, we try to use it somewhere in the compiler so that it's tested for bootstrapping. That's something that makes sense. We have a lot of optimizations, and I'm not going to go through these. There's more that I have had here. These are some of the most important ones. I'm referring to instruction selection, register allocation as optimization. We could just call this being not stupid. Of course, you're going to have to do this, but yeah, we could be stupid here and not do a good job of instruction selection, register allocation. I kind of put this on here because doing a good job of register allocation is something we struggle with. We had a fairly decent, very fast register allocator for version 84, and we replaced it with a graph register allocator as kind of an experiment. It makes the compiler run significantly slower. So it takes when we first did it, we had like 4-second bootstrap times, and it turned to 12 seconds, and that was completely unacceptable. We got it down to where it was like 6 seconds. So the graph register allocator is definitely costing us a bit extra to run, but it does generate quite a bit better code. On the other hand, we had some troubles with Matthew's RacketCon Steam project, where he was generating programs that had bazillion variables, and the quadratic representation of the live sets and conflict graphs were biting us. And so we had to do some things to say, well, if you have that many variables, you have to kind of back off and say, we're gonna maybe just immediately spill a whole bunch of them, and then do the register allocation on the rest. So you try to determine the right candidates. Yeah.
Are you looking at the puzzle piece register allocator?
No. Where's this?
Jens Paulsberg and one of the students.
Basically, the question for the video.
I'm sorry, he asked if I looked at the puzzle piece. Register allocation algorithm by Jens Paulsberg and students. No, I haven't. We can look into. Or something for somebody else to look into.
I think you're on the move, Robbie.
Yes,
You said the graph coloring algorithm generated better code,
yes.
but it made the compiler slower. Is that because the compiler doesn't use? What do you mean by better code?
I mean, it generates code that it means that you take a non-compiler program and compile it, it runs faster. But the compiler itself runs slower because the graph coloring algorithm is slower than what we had. We had one that was quadratic before, but it was quadratic on the number of registers. Now we have one that's quadratic on the number of variables in the program. Right? If you have 5 variables, that's great. If you have 5 million variables, that's not so great. Documentation, don't go into this either, but obviously we have some, and these are the things that have driven a lot of the bug discovery and performance problem discovery. All right, now we get to the actual definition of language. Here it is. A little bit longer than the original one. I don't expect you to read this, but we're going to go through piece by piece. Don't usually like to go through code, but it's kind of fun. So this version checks for improper lists, and it checks for cyclic lists. Of course, we didn't want do these checks and actually pay for them. So we tried our best not to actually have to pay for that. We wanted a version that actually runs faster than the simple one that did these checks. Okay? So it's optimized. We used direct recursive loops. That's the first obvious thing to do anyway. Okay? We used fixed sum rather than generic arithmetic, and we can get away with this on chasing because the length of a list is always going to be a fixed sum. Fixed sums are designed to be big enough to hold the length of any object. So you can always count on being able to represent the length of a fixed sum. You have to think a little bit the way the algorithm is written to make sure that it actually does fit. And unfortunately, it's hard to test. Make sure that it actually does fit in the fixed sum range because you have to have a machine with enough memory to do that. And have enough and few enough other things in the system that you actually get up to the danger point. Pretty much pretty difficult. But it turns out that if you study the code long enough, you discover quickly that it's not a problem. We unfold up to 10,000 iterations. This is just a manifest constant in the code, which is normally a fragile thing, but I think it's only a fragile thing if you have the manifest constant here twice, once here and once there. In one place, it's fine. So it's just a random number that we chose. So up to 10,000. So you'll notice a distinct slowdown after 10,000 for length. Actually, you won't notice much of a slowdown, but you might notice a little slowdown. And then after 10,000 iterations, it goes in cycle checking mode. Why can we wait till 10,000 cycles? Well, who cares if you get lost in a cycle, even if it's a small cycle, and go around it 10,000 times, you're in your case anything. Yeah.
Ken, how much of this is generated?
Really?
Because the first two conditions clearly look like contracts you can write down and generate it there.
That's true. It's open source.
Okay. Tomorrow.
It's so nice to be able to say that, isn't it?
I wrote the letter then.
Yeah, I have to say I had mixed emotions. Colleagues came to me and said we should open source it. First of all, our project at Cisco got canceled. And so they wanted to make sure that chasing got out and we didn't bury the dust in history. So they came to me and said, let's put together a proposal to open source chasing. And I said, no. So part of the reason I came here was to get out from under this albatross and not have to deal with it anymore and not have to babysit it forever. So I was definitely ambivalent. I do think it's a good thing for the world, and in many ways it's a good thing for me too. But I do have this, internal instincts toward it, which makes me have to watch over it. It's going to make me have to watch over it until I'm dead, I'm sure, maybe even after. So I do have mixed emotions, but it is nice to be able to say you can do it if you want to. All right. So the actual definition of length, just a little premiere of this. This is the outer part of the code we just looked at. There's just a couple of helpers that signal errors, and this oops, think of that as assertion violation. And length calls list length with a foo argument of length. And the reason why it's written this way, I wanted to have the exact code. I thought about rewriting this to just have to find length here and forget this. But I wanted to write it the way the code is actually there in the source base. And it's because list length is used by other procedures. Okay. Helper. So we have helper that's used by anything that has to check to ensure its arguments are properly. All right, so we have a hair loop, right? So for those who are not familiar, the way that you check for cyclic lists in any system is one way to test the leaves is using the tortoise and hare algorithm. You set a tortoise going along the list, and you set a hare going along the list twice as fast. And if it ever occurs that the tortoise is actually ahead of the hare catches up to the tortoise, that means you have a cycle. And you can prove that if you have a cycle, the hare will catch up to the tortoise. It will never jump over it. It never just keep going past it. So that's the tortoise and hare. You start out with just a hare loop, and I call it the hare loop instead of the tortoise loop, because this one goes 2 steps for every iteration of the loop. It's just like the tortoise and hare algorithm. So when we get to the tortoise and hare loop, you'll see that the hare is going twice you have 2 steps for every iteration, and the tortoise is going 1 step for every iteration, and that's how the hair goes faster. So up to 10,000, we just do a hair loop. Only the hair is running along. Of course, we replace the null test with a pair test. Okay, so we have only 1 test. And this is the test to keep going. If it's a pair, we keep going. Okay? If it's not a pair, then we have an additional test to make sure that it's actually null. Otherwise, we can cross the test. That's both here and here because we have it on null loop. Actually, we did this in the even in the file, we probably share some of this code. We were doing it at the source level. And then first, the inherent loop, because that has a hair and a tortoise, and the hair is still going around twice as fast, but now the tortoise is only being advanced 1 time per iteration. We have the additional check. Instead of the less than or equal check, 10,000, we have that's for whether the hair is equal to tortoise. Okay. Now, my imperative friends would ask me, why don't you just set a bit? Say you've been there. You don't have to do this massive thing. But of course, we're functional programmers. We have thread systems. Okay. We don't want to have to go reset the bits. So that's why we use the tortoise and hair algorithm. Okay. So this is length. Questions on that? Okay, well, so when TS asks if anything's generated, there are some optimizations generated, but not the one, not this code. The first one up here is actually generated. Don't actually do this manually. It's done by the optimizer, and it's done in a way that is independent of which procedure performed. So if length actually gets a proper list constant argument that you can actually see at compile time, or that can actually be pushed to where it can be seen in compile time, then length will be folded. And we'll just get this folding through. The compiler also, and this is an explicit optimization for length, reduces rel operators like equal or fx less than or equal or greater than, whatever. It'll reduce this with a code length inside and some small constant that inline code that does the simple, just a couple of parse encoders or a couple of coders and checks. Okay. And the benefit of this is that if you have a million length list and you want to see if it has at least 1 element, by doing greater than equal length E1, obviously this takes a lot less time. I'm going to compute the length of a million length list. Okay. Yes.
It says K there. Does that mean that if there's a variable or something, it won't kick in?
Yes. Exactly what it means. It has to be a constant.
Have you considered doing something for the situation where you don't know what the constant is at compile time?
No, that's open source.
I'll suggest that. Like 50 times I see students handing code like that.
The thing is, they'll suggest it to you back though. I put my code up on GitHub. You can fix it yourself. No, I mean, I would hate to do something that would slow down length. Right? And to be honest, I have mixed emotions about doing this optimization because this isn't really something you can count on. You better not be counting on this, and this violates the continuous assumption, right? But if K isn't a small constant, all of a sudden this costs a lot. Right? So you say greater than or equal length E12, and E has a million length list. It takes a long time. Right? So I have mixed emotions about this, but it's very handy, and I do think that 99% of the time K is going to be small if it is a constant. People rarely say, "Is my list got 100 elements?" Yeah.
So if E is cyclic, then this turns an error into non-error.
I'm glad you asked that. No, actually, what happens? There's a constraint here is this length call has to be an unsafe call to length. We have a notion of safe and unsafe primitives. right? And if you run your, you can either specifically make it unsafe by putting a hash 3% in front of this. Optimize level 3 historically means unsafe, right? Otherwise, it's safe and it won't do any optimization. So you can do a whole program on optimize level 3, or a whole sub-part of your program on optimize level 3, or you can do an individual primitive. And this one has to be optimized level 3. This one doesn't, but this one does. Yeah.
I think it's actually a critical optimization because you want to attract people from other languages. It's a very common paradigm to write, instead of writing null off, you write length of list is 1, something like that, or 0. And people who come from, say, Python turn simple linear algorithms into quadratic algorithms, except to catch them like this.
Right. Yeah, and then they also use assignments all over the place. So it would be nice to have an assignment elimination pass. We have an assignment conversion pass, right? It converts assignments into form, but we don't have an assignment elimination pass. I kind of wanted to have one of those, or just for those pieces of code that are transliterated from some other language. That's a good example of that. All right, and then also OpenCode's length E is a loop in unsafe mode because I mentioned the unsafe constraint on this one.
Okay.
Yeah.
You mentioned in the introduction that one of the nice properties you want to have for shell scheme is uniformity.
Yeah.
Now you are making special cases for length.
Exactly. That's what I said. I said this breaks. That's what's one of my mixed emotions about this.
And I gave you an argument for why.
If I go from length, I don't even remember what K is. I can't even tell you. I don't know myself. I know it handles kind of the device K that I'm likely to use.
Yeah, but my point was mostly if you write your own length for your own data structure, then you will not benefit this kind of optimization.
That's true. Yeah. It would be nicer if the compiler optimizes itself. But we actually did some experiments with loop unrolling. William Bowen's I don't know if he was involved or not.
Yes, you.
Were you involved in that? Yeah, you were working on it. Yeah, you and I were working on it together, right? Yeah, and we did some loop unrolling and really had spotty results. So yeah, that's another place where it'd be nice if some of that stuff were done automatically. And I have to mention this open coding of loop of length is a loop in unsafe mode. There's really nothing more than what you would get if you expose the source definition of loop to the inliner. So it's not. There's a sense in which our compiler is really deficient in that the primitive definitions aren't exposed to the compiler, and so the compiler actually has to do explicit inline definition. And this is just a replacement for the implicit inline. The implicit inline you get, we expose the definition to it. So another thing that done better. All right. Now, onto the stuff that's really generated. As the system grew and got bigger and more people got into the system, so it wasn't entirely in my head, it became obvious that to actually have control over this system, we had to have declarations for the primitives. It was too often the case that we would have something that didn't work quite right, and because it wasn't declared. And we'd have a variable that wasn't bound or something that was bound that should have been bound. And from data declaration helps us get around this. It started out like very simple, just this is a primitive, or this is a syntactic form, and we used it as a check to make sure that we didn't have anything defined. It wasn't supposed to be defined, and that it was defined. It was defined the way it was supposed to be. And it grew up, and we added the source optimizer to have a set of optimization flags, and those are sitting here. And I told them discard true or optimization flags, and we used it for identifying when we had a primitive that was supposed to be part of the IEEE or R5 or X libraries as well. So this is the actual data declaration for length, and it specifies there's actually a wrapper around it. There'll be a whole bunch of them in here. I just selected one for length. This says all the ones in this group are in the RNS library and also in the RNS base library. And implicitly, everything's in the shade scheme library. And these flags are shared. These are primitive procedures. Okay, and this is actually kind of redundant. I don't think I'm not sure if I have tests for it. And then this is the signature, which we added basically to do testing. And then we refined it to when we started working on type recovery. And this one just says we take a list, which has to be a proper list. List means proper list, and returns a length, and a length is a non-negative fixed sum. And then it flags optimization flags. So going through, a lot gets done as a result of these flags. A lot of optimization and testing and documentation work gets done as a result of these flags. So the optimizations, if it's marked prompt, we don't do a procedure test on it. Primitive variable names are not modifiable. You can't modify. They come from a library that's immutable, and so you can't modify them. So you know that they are always going to, value of cons is always going to be a procedure. And we fold calls the primitives marked foldable. Okay. Most of them are marked MI-foldable, machine independent foldable. Okay. Some, for when we're cross-compiling, have to be marked only foldable because there's some machine dependency that breaks it, like maybe we'll have different floating point representation or something like that. It would be at a different neutral size. Right. So you can't do MI-foldable. You can't just fold fixed on width. Right. If you're cross-compiling from a 32-bit machine to a 64-bit machine, because the way folding works, it just calls the built-in primitive and sees what it returns. And on a 32-bit machine, it will return a different value from what it's supposed to be in 64. We discard unsafe calls with IDs marked discard. So if length is in that context after optimization, usually if somebody writes such code, then it will fall away. We don't need to keep around to do the check. And then this is true. This should happen to be end up in a test context, which isn't that unusual because if it could be inside the floor, for example, that's part of the floor. Then we know immediately it's true. By optimization ends up in the test part of the floor, then we know that we don't have to do the other part. Yeah.
How do you prove that these flags are correct?
We don't. Sometimes they're not. This is one of the places where we have bugs in the system.
You said that you wrote these in part to inspire the test notes. Does that mean that the tests assume that they're correct? Or do the
Yes.
tests assume that they're not correct?
The tests assume they're correct. Right?
So then finding the ones that are wrong is challenging.
No, because we have, if it turns out that there's a lot of redundancy in the test suite. So a lot of times you'll find the flag is actually incorrect because a test will succeed when some other test will fail. If only automatic test will succeed and some other test will fail, or vice versa. Yeah.
Could you use random testing to read these flags and then check them against these innovations in some kind of a way?
We'll get that.
Yeah, cool.
Sorry. We have some other optimizations that are flags that aren't shown for length because they aren't appropriate for length. Pure and unrestricted and abort. Here's a little funny one. Think length is pure, right? It always returns the same result no matter when you call it, right? No. You set foot over list between one call to another. So you can't say move a pure call to length from here up to here, because there might have been a set footer here. So length isn't pure. But some other primitives like plus are. We can, if we have something that is marked unrestricted, we can always treat it as an unsafe call. Unsafe means it doesn't have to do any checks. And it's unrestricted, meaning it doesn't actually have any checks on its arguments, like cons. It doesn't actually check its arguments. It has cons and two arguments you want, but then we don't have to worry about that. And that's true, so we can discard a call to cons even if it's a safe call. If it's marked abort, like error is marked abort, then we can tail call it no matter where that appears. Of course, this is kind of at odds with debugging, so we have debug level 3 and we don't do this optimization. And we have this marker called pariah, abort, and we have a flag, we have a form or a notion in the compiler and form in the language called pariah, which says, this is unlikely to happen. And so the things that are marked abort, like error, will say, this is unlikely to happen. Well, that may not be true. You may have written your code so that it calls error a lot. You have exception handler out there. I think the fact that we call them exception handlers should be a key, that these should only be used for exception situations, and it's fair to treat them as pariahs. And what this effectively means is the code for pariah branch will get pushed out of line, pushed away from the main line code, so that your straight line code will be non-pariah code. This actually has a beneficial effect on cache, structure cache. Tests. So this is the test. It verifies that IDs are bound appropriately. And this verifies that argument count exceptions are performed. And it verifies some argument type exceptions, including for cyclic plus. And the answer to the question is no, we don't actually generate random objects. As again, we have a set of handcrafted objects that we throw at it. So if you have a list, we have a set of non-lists we throw at it. Okay. But we don't throw a set of random things at it. Maybe we should. And then we have, of course, a lot of handwritten notes. We get a lot of mileage out of the bars, and we get a little bit more because even the documentation, we verify we've documented all and only the things that are actually supposed to be documented. And we automatically list the libraries. We don't have to explicitly put that in documentation that's generated. We could do more. We don't do more. We could do more. We could check to make sure that we didn't claim list has that a list can only take 2 arguments, when in fact it can take any number of arguments. So we could write that documentation and we won't get an error. That would be nice to have that checked, and maybe even some text or something like that generated if we can do so in a non-stilted way. All right, this is my last slide. What's missing? Book on implementation. That is number 1. We have a bunch of papers. They're almost always out of date with respect to what the system actually has. By the time it comes out, it's published and well out of date now. And besides, they often describe something a little simpler than what we've actually implemented. It'd be nice to have a book. You know, it might be really big and nobody would buy it, but it'd be nice to have a book that describes it. Additional tests, of course, always useful. We don't have any tests for the expression editor or any other interactive use of the system, which is a big hole. An open source benchmark suite. I have a benchmark suite full of closed source programs or programs that have licenses. Well, don't have licenses, right? They have copyright notices and no licenses, and I don't even know how to find these. So when we open source Shadescape, we didn't put that out because I couldn't put that out. In fact, when Cisco took over Shadescape, I can't even give them these things. So those had to be removed from the system. So I have them and I use them for my own benchmarking as one version to the next, but it'd be nice to have an open source one that was that actually tested all the things in R6 or S, like really tested records. And also test a lot of the other things in Shadescape that aren't in R6 or S. It'd be nice to run those benchmarks under continuous integration. We run tests under continuous integration, but we don't run benchmarks. We don't have benchmarks. We also we might run out of their time with this. It'd be nice to have additional optimizations. There's been a couple of attempts at type recovery. There's one in a long-standing pull request right now that I've kind of been sitting on, like about 12 or 15 other pull requests because I don't totally understand them. I've suggested that for something as complicated as this, we need a thorough document describing it, and that would be a rule of thumb for me and for anything in the future. If you're proposing a really complicated new thing, there needs to be a paper, and it needs to be refereed, and then we'll be much happier doing it. We'd also be happier doing it if we had a notion of a release and stable and unstable versions of Shadescape, which is something that we ought to have. So we ought to have a stable version or unstable version where you can pull just almost anything after a few rudimentary checks. See if that feature causes trouble over a period of time, and embed it more over that period of time, and then finally put it in stable release. Faster object file format. We're using our circa 1985 fast load format, which is not the ideal. It's a little bit improved since then, but not enough. I'd like to have better profiling tools. Really, the execution of profiling is incredibly useful. It helps us run We can use that to determine if our test suite is actually covering our source code base. Right? So you can say if you use execution profiling and you find that there's a lot of code in the source base that has 0 counts, you aren't testing your source base very well. So that's very useful for that. It's very useful for finding hotspots, but it's not that useful for finding the parts of the program that are really taking the most time, because your hotspots, places where you're executing most often, might be an addition operation, and there may be some call to the collector that's only 12 times. Something else is 100 times. It's basically free. But it's very useful, but it's not as useful as it would be if we had true. And this is just what's missing from supporting reliable and efficiency. There's lots of other things.
Thinking about your third line there, the Racket community has plenty of programs that get run a lot and would be great if they end up in the benchmark suite, because that would mean they'll get faster.
Yeah.
So that might be a way that the Racket community could.
Yeah, I mean, obviously we should have one for Racket as well, right? But it's going to be different. And those programs would exercise the Racket and scheme underneath it. But it would exercise Shade scheme in a completely different way, I think, from the scheme benchmark. You'll see versions of those. Okay. I think the Racket is probably test the style as variants of Shade scheme, not as much as that's full of language. Okay.
And we have 5 minutes for questions.
You have a lot of performance wisdom that you've built up. Can you share some of the surprising things, like is cache pressure more important than register coloring, or?
I don't know. It's varied so much over the years. I guess the surprising thing is that I'm always surprised. I mean, I remember back in, I had some optimization, Bob even I had an optimization back in that we were absolutely certain was golden, and we ran it. It was ran like 100 tests, and it was 15% faster. We went off to lunch and came back from lunch, and we reran the same thing, and it was 15% slower. Benchmarking is very frustrating. Cache behaviors, there's one of the most confounding things. Presumably over lunch, some of the program got in, bumped ours out of memory. I remember ours got pulled in a different part of memory. Cache alignment was different somehow, who knows what. We cannot explain how that happened. And this happens all the time. It's very difficult. Of course, we don't want to go back to the days where there were no caches. But sometimes I do.
So for a long time, you used the rule that what you put into your compiler could not slow down the compiler.
Yes.
How often have you broken this rule?
Not very often. Certainly adding the graph problem register allocator and even the switch from the non-NFS to the NFS compiler broke that rule.
Twice?
We worked really hard to I don't know if it's only been twice.
But you really, this is a rule.
I don't know what the expression editor is, but eventually use times.
So if you use T shell or born shell and you hit the arrow key,
Yeah.
you can get to your history.
Yeah.
Then you can use command line editing tools to edit it. You say use T shell and you do for each, right? You do for each and you have like 5 lines, and you hit up arrow, you get for each.
Yeah.
You don't get the other 5 lines, right? So in Shade scheme, the expression editor is just like that, except you get the whole 5 lines. You can edit the whole 5 lines. As simple as that. But it was a lot of work actually, and it was fun. It was kind of untaxing work just writing scene code and a little bit of C code to do version stuff. But just writing scene code. I'm not thinking about having scene code that's generating scene code, or scene code that's writing, or C code that's collecting, garbage collecting C code, garbage collecting things and causing errors to happen that don't manifest with garbage collection cycles. Very, very fun.
I'll let others go.
In this talk, you focused a lot on length, and I feel like it's not totally obvious. The thing that we should feel is that you've done the exact same process for all 300 primitives that are in R6RS and all every single. We
I would say
into every library.
Yeah, so we haven't done that for every single. That happens to be something that's used by a lot of programs, and so it's got more focus than other things. But things like ASSQ, yeah, focus on that and various other things. So yeah, this isn't the only thing we've optimized. Quite a few other things. Yeah.
For the NanoPass compiler, why do you feel like that's worth making the compiler a little bit slower or something?
So the old compiler, good question. I think Andy probably addressed it. He talked about it before. The NanoPass compiler breaks the compiler up into 1,000 little passes. And actually, Jordan Johnson back there wrote an early version of this. And it breaks the compiler up into a bunch of little passes that each do one thing. The old compiler had 6 passes, 5 passes, or something like that, and they all did part of everything. Right? And so a lot of times you'll come up with an optimization that really had to go after that one and before that one. But when these two are interleaved in the same set of 3 passes, how do you shoehorn this extra thing in here? And then these passes just get larger and more complicated, and you like juggling 100 things at once. The NanoPass compiler allows us to break it up, but now we can add optimization more easily. One example of that was that we improved the closure optimization. It was so much easier. It's a fairly complicated optimization, and it was so much easier to add to the NanoPass compiler.
To follow up on that, post NanoPass, can you talk about other optimizations that would be on your punch list?
Well, we lost block allocation when we did the NanoPass compiler, never came back to it. The only thing we ever blocked allocated for was closures in the whole block. You have to have left bracket allocate all the closures in the block. We lost that, and it would be nice to get that back and better. And I mentioned type recovery. There's been a couple of attempts. Michael Alex is here somewhere. Yeah, had an attempt that sadly made our compiler more than twice as slow. Got rejected as a result of that, and I never took the time to go and try to make it faster. Someday I might do that. There's another one that's been a pull request that I have only kind of at arm's length followed through and keep. That would be nice to have one that actually does that, so that your optimized level 2 programs, the ones that have to do checks, run much closer to the speed of the optimized level 3 programs. You're not as tempted to use optimized level 3 when you have something nice to run with it. A couple, I'd like to get floating point performance better. We really need better floating point performance for some programs. That's one place we're not uniform in our performance curve. And every floating point operation has to unbox floating point structure and rebox it. It'd be nice to get some of that in there. Yeah.
You mentioned we're interested in the history lesson with Cisco. You mentioned there's a project cancellation for Cisco.
Oh yeah, it's also been started. We started. That's the best news, right? So it got canceled because we started.
Oh, nice.
But the bad news about that is now I can't talk about it anymore. But it has to do with networking. And we are using ShadeSteam, and we do have one customer using the shipping product right now. And it's possible to have another one. We're scheduled to have something else. And there's actually, our project actually got a lot of traction inside that.
Well, awesome. This has been amazing. We'll have a break for about 25 minutes. Let's take that. We'll come
come back at 10:40. If you're presenting in the next session, please come up and test your laptop.
Yeah, that's what we're doing. It's possible.
Anybody have an HDMI to me display footage out there? I forgot mine.
No, we need a person to probably make sure that it's working and adjust it, because I can't be here and up there.
Go find someone then.
But that should be easy. In fact, Paulette, hey, can I hire you to sit up front?
Sure.
Great, thank you.
Why is that?
Come, take your break, but can you come back a few minutes early and talk to me?
Sure.
Cool. I want you to watch this camera.
All right.
All right. Sorry.
Okay.
Sorry.
Are you leaving?
I am.
Well, thanks for doing the video stuff and everything like that.
All right.
And I think that project is pretty cool. I'd be interested in hearing.
Yeah, sure. You want to come up quickly? I'm just setting up the laptop. Who are you, by the way? Chris. Yeah. Okay. You need to sound familiar, actually.
I'm working on
Ah. Oh, cool. When? Okay. Well, cool. I look forward to seeing it. Yeah, we should chat. Okay, yeah, cool. Anyway, it was good to meet you. Good to meet you too. Hey, likewise.
After Mike Stockton was brought in after 92, these British folks took Canadian people know. And so, oh,
tester laptop.
Okay, a Olympic rower, a real silly guy, okay? Stuff's an attitude.
Really?
And anyway, Mike Katie turns out to be
Sorry, I'm gonna need to. Can I ask you to have this conversation 5 feet over? Thank you.
So there's several. He also looks like Mike Katie. I won't say, although I know I think I'm just looking at the coffee at the same time. I would say, but he also, he's kind of a champion.
Hello. How are you doing? Oh, sorry. Okay.
Yeah.
Hey, Jay. Everything going well?
Well, the live stream that we put out was apparently useless, so we're moving up here in hopes that it'll be better. But the recording went well, so far so good. Yeah, yeah. Did you find a Windows computer?
Yeah, I borrowed Matthew's kid's computer. Gonna still go to Amazon and see if we can get it. But it's working.
Yes. I should mini trust. Well, I'm not going to work. Anyway, sorry. That's a nickname, Jay. Oh, he's back here. Oh my God, Jason J.
I call myself so.
Michael.
It's fine. I hadn't been requesting anyone else do it. I just didn't mind self-referencing. Sorry, anyhow.
Sorry. Can you take 3 steps that way? All right, good. Sorry, it was just you. I was making sure that it could focus and it wasn't just on.
Anything to make what you're doing work better.
Yeah, it seems to be working.
Yeah, I was wondering what that book would be. Would it be So I don't know if you call that Twitter, but it's a tweet. So I'm sitting there watching you. Not all programming, but we had Barry when I was on the we have and we weren't winning some medals after 96. Let's try going there. We got my Katie. Each turn, you have flowing team. And it's sort of like now 2004 was on the 4th place. 2000 was 4th place. And so like in rowing, Mike Katie is like he took our program, turned it around, and made it sanity. Because he has ruthless devotion to quality, and he sets a very high standard for what he wants. So remind me about using it in that sense, but also you make the way I describe it is like chisel construction and setting it. And then also you reminded me of my old man, I was also an Olympian champion personality and making the best in life. And he also so anyway, if the seller comes back to me, who's in it, so it's just like, I wanted to know if there's anything in my mind. That's it. But thanks for, it is. And thank you for facing it. Well, like first and fourth, right?
All right, so there you go.
Oh my God.
Let me know.
Are you okay?
When are you going to be there?
I don't have a speaking slot. I'm just running. I just want to run my game. Probably during lunch.
Probably during lunch.
Yeah. It doesn't look like it looks like during the break.
Yeah.
Or we'll see. We'll see what happens.
Oh, yeah, that would be fun.
Yeah, we got pretty decent.
Or it could be fun with some like hardware engineering, but
yeah, that would be cool. That would be cool. Have some, I wanted to make it so you could do it on touch screen.
Oh yeah.
But I tried it on some touchscreen computers, and I don't know how to do like the equivalent of building something. Because usually when you want something on a touchscreen, it doesn't even work like a right thing. It gives you a
That's right, yeah.
or something.
Yeah, it's
I mean, obviously there's something that I can probably do, but
yeah, I'm not
also I don't know it.
might override the context menu and then it's
Right.
I'm not sure.
Yeah, I don't know that Racket is going to want to way to do like touch specific windowing stuff. Yeah, I don't know. We shall see. But I don't
When more people spawn on one team, then you all share a base and another base somewhere else.
There are a bunch of different scenarios, but the RacketCon scenario is like two teams, and so like a whole bunch of people. Each person who joined the team, they get put in like a little timer that's auto spawn. So like if 5 people join, you get like 5 timers, and then they share the same base. And then you have to like go billion balls.
And the 3D version would be pretty fun. I was working on Space Orb like 3-4 years ago.
What's Space Orb?
It's a like FPS animation rack.
Oh, cool.
It was just a little one. I was planning on adding like you could drop mines and stuff. If you go to oplat.com, you can see.
So, this is my laptop. Please do not kill it.
Yes, let me put my liquids away then.
Oh, no, I mean, you can bring liquids near it.
Okay.
If you do kill it, I won't come for your head. But I would like you to sit there, if I may. So, basically, feel free to put the laptop on you or under you or wherever you want around here.
Okay.
This webcam here should, well, yeah. So it should be able to read the stuff on the screen.
Okay.
So feel free to adjust it.
Yeah, it's a little.
It's not going to be amazing. There's only so much that the shitty webcam can do. Can I give you my phone number, though?
Yeah.
Or
I
can
think
you
I
give
have
me
it.
yours?
I think I have it. I'll text you.
That way I can text you if there's a problem. I will be sitting back there. If I need to run up, I will, but I would rather not get in the way of everyone if I can help it.
Yeah. There we go. Cool.
All right. Muchos apreciado.
Yeah. Do I have to hit record or anything, or just
Sorry?
make sure?
No, I mean, this has any controls, so best you can, this is the best effort.
Yeah, it's kind of hard. I think this is the best you can do. Yeah.
Like something like that is about as good as it's gonna
Yeah,
get,
I think so.
unfortunately.
Now it's back to that.
Yeah. All right. Well, hopefully. Wow.
Yeah, this is kind of bad.
So the thing is, most of the slides generally will have bigger text than this.
Yes.
And so that makes them read.
Yeah.
It's hopeless to try to get that to show up.
Yeah.
So if you could just sit there,
Yep.
man the station,
Yeah.
be wonderful because you are and stuff. And I appreciate it so much.
Is it cool if I just like sit on the floor here?
Sorry?
Is it fine if I just sit on the floor here?
Oh, absolutely. You do you.
Thank you.
You're doing me a favor.
Oh, okay.
So,
Yeah, no problem. Yeah, I'm sorry about the quality.
No, it's not your fault.
Oh, no, I don't.
It is not your fault.
Yeah, I'll take care of it.
Cool. Much appreciated.
Yeah. Just text me also if there's any problems.
Will do.
Apparently that's a question.
You knew it, but you did it anyway.
I didn't. I don't.
Yeah, it doesn't seem like
Most people are like, you need to stop. No, like, literally made this.
All right, everyone, let's get started again. So our next presenter, well, our sort of our first non-keynote presenter, right? So we're entering our next block of talks, and so our first speaker is Jesse Taub. He is a assistant professor of instruction at Northwestern. He's going to be talking about a language he's designed for teaching. So.
So what the heck is this?
Python. You might think it looks kind of like Python.
It's got a HUD.
Yeah. But it's got a HUD. And it has lets in it. So it's not quite Python. Let's go back a little bit for some context. This is DSSL. Let's go back a little more. So this is DSSL2. It's a hash lang for introductory data structure students. So like pretty early computer science students who are still learning data structures. So I'm gonna show it to you. So here's the context we needed for that first slide we started on. We're in hashlang DSSL2, and unlike Python, DSSL2 has structs. Because if you're building data structures, that's a thing you want. So we have one struct nil, which is empty. And we have another struct cons that has two fields, car and gooder. And using those definitions, here we have a class now, and the purpose of this class is just to let you build a list in order from front to back. So it has two fields, two member variables, whatever you want to call them. They're private. One of them is going to be a pointer to the first node of the list. The other is going to point to the last node of the list. And you can go through and add things to the end. And when you're done, say build, and you get back the list. Okay, so this is just an example of DSSL2 code. But before we look at it in more detail, I'm going to take you back and explain why we're doing this. So here's the roadmap for the next 16 minutes. First, I'm going to talk about what DSSL2 is for and why I made it. Then we're going to talk a little bit about what it's like as a language, a little bit about how it is implemented, and then some evaluation. Okay, so what's it for? Well, it's for teaching data structures. It's really just for teaching data structures. It's a teaching language. So why would I want to program in it? Is a question I ask when someone shows me a new language, and the answer really is you wouldn't. I mean, I have fun implementing data structures in it, but it's not a general purpose language. It doesn't have things that you need in a general purpose language like IO. It has structs and a few other things. So you wouldn't, but maybe if you were teaching data structures, maybe then you would want it. I'm not sure yet. I like it. Maybe you will. So why does it exist? Well, let me tell you a bit of a story. I first taught data structures 3 years ago when I started at Northwestern. And starting out teaching data structures for the first time, I might have been a little bit naive. And so one thing I said told the students was, you know, I don't really care what programming language you use. We're learning data structures, not a programming language. So you can use whatever language you like. Just let me know whatever languages you want to use, and I'll prepare the homework assignments in those languages. So there were about 2 students who wanted to do C, and they did fine. They knew what they were doing. There were some students who wanted to do Java. They did okay. There were some students who wanted to do Python and Ruby, and they did okay too, but the vast majority of the students chose C++. And what happened with this was it was a disaster. I got code like this. This was probably the more common problem. And then the students who weren't doing this were doing something. I don't know if you think this is better or worse. I mean, it's not undefined behavior. It's just a bug that you'll never discover. So this is what they were doing in C++. And the reason for this is these are the prerequisites to take data structures at Northwestern. They have 10 weeks of pure functional programming in beginning student language and intermediate student language. So how to design programs for 10 weeks. And then they have 10 weeks of C++. So they've just done C++. They think they know C++, but no one who's been programming for 20 weeks, 10 weeks of which are in C++, really knows that much C++. And so at this point, I had a choice of what to do as this, you know, we're now 3 weeks into the 10-week quarter, and they're all trying to do their homework, and they can't do it in C++. And so what now? Well, so one possibility is I could try to teach them C++ with a side of data structures. Because if we're going to try to do data structures in C++ for 10 weeks, it's going to turn into a C++ course. There's just
too many details that they need to understand to get these things right. So I rejected that idea. Another possibility would be teach some other language that maybe we'll have an easier time with. But I think even Java is complicated enough that we're going to spend half of those 10 weeks learning Java. Now, we could teach data structures in a language the students already know, but the only language they know that's even, I mean, they know intermediate student language. And these are your typical introductory data structures, a lot of arrays and mutation, and the language just doesn't support that. So that's not really an option. So what I came to eventually was teach data structures in a language that the students can easily learn. And so we need a language that is pretty simple, minimal, just does what we want for data structures. And so maybe we could do something like Python. The students all like that. They actually want to use it. But I think it has some problems for teaching data structures, like it doesn't have the ingredients you need to define data structures, at least not reasonably. And it has a whole bunch of other stuff. So what about a teaching language? Something like intermediate student language or beginning student language designed specifically for teaching particular concepts, but in this case for data structures. So that's what I did. So for the rest of that quarter, we used the teaching language called advanced student language that already existed. And this is just an example of a random binary search tree insertion in advanced student language. I think it's pretty reasonable code, except I didn't like the begins. I said this is not a language for imperative programmers if I have to write begin everywhere. Maybe that seems small, but it was annoying. So the next year, we used DSSL. DSSL was a slight change to advanced student language, still S-expression syntax, but just a little bit less stuff in your way for expressing imperative algorithms. So this is the same function for inserting into a randomized binary search tree in DSSL. Okay. And I thought that it worked pretty well, but the students were not very happy with it. They felt like this was more of what they've been doing in how to design programs. So someone, not me, promises them at the beginning of their program, you're going to do this weird language for 10 weeks, and then you're going to do something different, and then you're going to do something different. And so by giving them something that to them looked the same was in a sense breaking this promise of you're going to only have to do this weird thing for 10 weeks. Now, personally, I like this weird thing, but I also want them to be not focused on that and focused on data structures. So really my goal is to get the programming language out of the way and just look at data structures. So here's the same code in DSSL2, which I used last year for the first time, and I'm using again now, this quarter. And so it's the same code. It has pretty much the same semantics, but it looks like Python, and that makes the students happy. All right, so that's how we got here. What's it like? What is DSSL2 as a language? We've already seen some examples of it, but let me just give you a description. So it's strict, it's untyped, and it's dynamically checked. So like other languages we know, like say Racket. It's not surprising that it would be like that. Unlike say Python, you build your data structures out of structs, not dictionaries. So because we're in a data structures class, if you want a dictionary, you need to go make a binary search tree or a hash table or something like that. It shouldn't be the most basic data structure in the language. It also means that you have to think about what are the fields I want in my struct and declare them up front. You can't just arbitrarily set, properties whenever you want. So we have that. Python has what they call lists, which are dynamic arrays. We don't have that. We have fixed size arrays. If you want anything fancier than a fixed size array, make it yourself out of fixed size arrays and structs. Okay, so this is really, I think, a minimal setting for talking about data structures. We have boxes that are essentially tuples with named fields. We have boxes of arbitrary size. We can connect them with arrows, and we can do a whole lot of stuff with this. Now, it turned out last year, one thing that was a problem with this setup was students did not really understand data abstraction, and there were no facilities here for doing that. So for example, they would make a binary heap, that would be a struct with a pointer to a vector, a size, and maybe a predicate. And then when they're writing their code to work on this heap, they'd write the operations they're told to write, and then they'd access the vector directly in like some client code. So I said, this is no good. I think we need a language mechanism for helping them understand where abstraction boundaries are. So DSSL2, as of this summer, thanks to Vincent, now also has classes, very simple classes, and interfaces so we can express the idea of an abstract data type separately from its implementation. So this is what it has. We also have built-in support for unit tests, because I think that's essential. And in case you want them, we have contracts. That can be kind of fun. So this is the language in a nutshell. And then I want to just walk through a little bit more DSSL2 code here. So we're in an intro data structures class. We're doing fairly elementary data structures, at least at the beginning. I mean, we get up to some things like APL trees and Bloom filters, but we start with things like stacks. So here is an interface for a stack abstract data type, right? You can push, you can pop, you can ask if it's empty, in which case pop will fail, and you can ask if it's full, in which case push will fail. There are different ways you can do this, but this is, I think, pretty straightforward. And so all it tells us is the names of their operations and their error keys. We could add contracts on here if we wanted to, but I'm trying to keep things simple. So once we have this stack interface, we can implement it as a stack class, maybe one that uses a vector underneath. And so this is some of the code for that. So here we have a class vec stack that implements stack. There's a static check that it actually implements stack. So when you write this, it actually checks. So this code here will fail the static check because we don't have all the methods that are declared in the interface. And then we have fields. Fields are always private. We have methods. Methods are almost always public. It's a pretty simple. There's no implementation inheritance. It's really just what we needed to separate. Here is the representation. Here are the operations. So again, trying to keep things simple. I think class is probably the most complicated thing in the language. Here is the rest of the code. So you can see it basically looks like Python, except we have these lets. Why? Because I think that it's important to distinguish where variables are assigned from where they're declared. So I just think that's a mistake in Python, so it's different here. Here's an example of what the built-in unit tests look like. So we have a test where we create a stack, do a push, and then do a pop, and check that it matches. So that's the basics of what the language looks like. All right, how does it work? Well, it's a Racket hash lang. So that means I get a runtime system for free. I get parts of the compiler for free. I get an IDE with syntax coloring and renaming for free. And I say this is for free because it's actually a lot of work to get that stuff to work, depending on how complicated the transformations that happen in your language are. And I get a nice documentation system. So that's sort of the benefits of implementing it using Racket. And then on top of that, what do we have? Well, we need a custom reader for the Python-like syntax. So I'm using the standard parser tools / lex library for the scanner, and the standard parser tools / yak library to parse it. So here we're parsing a level 6 infix operator and sticking the location on it and stuff like that. These tools work well, and they were really easy to understand if you've used the original like C versions of them. So I do wonder if a community that is so interested in DSLs, why we don't have anything different than like vintage 1970s Lex and Yak. So that's something I was wondering about, if maybe there are better ways to do these things in Racket. So we have a custom reader, and then underneath that, a bunch of macros. So this, for example, is the implementation of while. Right, so we take a test and a body, we set up some stuff so that break and continue work properly, and then we loop. So most implementation is not even that, not very interesting. We just move the code around until it does the right thing. Okay. There were two sort of interesting difficulties in implementation. One is you can't just read symbols and expect them to work. Every symbol that ends up in your final syntax object has to come from read syntax. So I had to write this ridiculous function that takes a symbol, turns it into a string, opens a string port, sets up the locations on the string port, and then does read syntax on that string port to get back the symbol as a syntax object that's properly blessed so that I get links in my documentation.
Datalog has the exact same function.
Yes, that's how I learned it. So that's one thing. The other thing is, Scribble is not that great for non-S expression languages. So I had to hack at this a lot to be able to do things like express the syntax of class. And then it gets weird when you have things like an operator named vertical bar or an operator with a space in it. So these are some places where maybe if we actually want to seriously support non-S expression languages, we could support them a little bit better. I'm not sure how. All right, so I think I'm about out of time. Was it worth it? I haven't done any kind of real evaluation of this yet. What I can say is students seem to pick it up easily and they don't complain about it. I don't get badly indented code turned in. And they can't copy code off the internet. And that's true this year because the language has changed since last year. And we'll continue to do that. Cons. I have a language to maintain. And this is the thing I still wonder about. Would it be better for them to get better at C++ or learn Java rather than learn this teaching language? And that's, it's a real trade-off. We only have 10 weeks. We want to learn data structures. We want to learn other stuff. I'm not sure what the best way to do it is, but this is what I'm doing for now. So thank you.
We have a little time for questions. That's Ryan plugs in.
I unfortunately have 3 questions. I'm happy to leave them with those people. Number 1, do you actually handle automatic indentation in the editor when the students are typing?
So automatically indenting Python is not really possible as far as I know. Instead, I've changed the bindings for things like the tab key, so they do something sensible for indentation-based syntax.
Wonderful. How does equality work? Do you automatically get a reasonable equality for the virtual classes that you define?
I believe that by default you get structural equality for the classes.
So for writing test cases, for
writing test cases, but you can, if you write like an _ equal method, then it uses that.
Okay, and third, how many beers do you have to buy an instructor in order to get them to be willing to use your system?
Ask Vincent. He's using an extra.
You are not, no. Okay, thank you. It's wonderful, thank you.
Thanks.
Next up is Ryan Culpepper, who is research scientist, or research, what is your? Yeah, research scientist at Northeastern. And we all, at where?
I'll get there.
Hey, sorry. We all love and appreciate everything that Ryan's done because if you use syntax parse, if you use the macro stepper, there's so many things in the Racket system that Ryan is responsible for. So we're very excited to hear what he's going to tell us first.
Is this working? Yep. Okay.
And will I break the world if I stand over here instead?
Yes.
Is this okay? Great. So the story begins. Earlier this year, I was working on the crypto package, which was something that I started like 10 years ago because I wanted nifty cryptographic operations. It's a bunch of MFI wrappers around crypto libraries that professionals have written, meaning not me, and it provides common interfaces, convenience functions, that will be all. If you like crypto, check it out. And in the process of developing this, I looked at the ZIO files. I think I had a little bit of residual paranoia about ZO file size because I had recently been working on a re-implementation of the syntax template form to add some new features that got merged a couple months ago. And I was trying really hard not to make the code explode, and it's harder than you would think because there were some existing optimizations for code size and speed that I didn't realize I needed initially. And it was a fair amount of work to cram the new features into the same performance range. So that carried over, and I looked. And so here's what happened. I've thrown away some of the lines, but most of these look pretty reasonable. A couple tens of kilobytes, and then there are a couple of outliers. So the two that I'm going to point out are private metal compiled FFI and the main module. And these are bigger than the others, but the files, I don't have time to show you the code, but I'm not doing anything really crazy in those files, I don't think. They're not substantially longer than the others. They're not tiny, but why the big difference? Okay, so I was speculating, and I wonder if it's, no, that can't be it. And then I remembered there's a tool in Racket for answering exactly this kind of question, and I wrote it. So maybe I should try using that instead of just kind of. All right, so the macro profiler established about 2 years ago in June. I was at the airport, and I was like, I have this existing infrastructure. I can just reuse that. And a couple hours later, there was a macro profiler. So let's run the macro profiler on the first one of those anomalous modules. Okay, so Racco macro profile, crypto private nettle FFI. Nettle is one of the common cryptographic data libraries. And we get this output, and it goes on further. It says profiling, initial code size, final code size, and then it has a sorted list of things that contribute to the final expanded program term. And they're sorted descending in size. So define C struct is at the beginning, and it has total, which is a big number, and then define C pointer type has a total, which is a much smaller number. So it's probably define C struct's fault.
Bytes?
No, I'll come back to that. Okay. Big numbers, small numbers. wait just a couple minutes. Okay. And then if I do it for crypto main, then we see phase 0, arrow star, total really big number, lambda, 1/3 the size, and then it goes down from there. So it's small. I don't want to pick on Robbie. Aerostar has a pretty hard problem to solve, and the solution isn't really. Okay, so numbers. What just happened? Let's go through what the macro profiler is doing. Okay. So we've got a couple concepts. The numbers are not bytes; they are the term sizes of different points of expansion. And the size of a term is basically the number of atoms plus the number of pairs, and also plus the number of prefab structs and vectors and whatever else is in there. So if you write something like this, really, it means this kind of pair structure, and that term has size 7. Okay, and likewise, if there's an extra pair of parentheses, that term has size 9. Everyone happy with that?
No, that's fine.
That's an atom, yeah.
We can share.
I'm counting it. I've tried, no, should null be different, should null be, I don't think it matters that much. Yeah, I made a choice, and I might make another one tomorrow. Okay. A macro occurrence is a distinct expansion of a macro. Okay. So let's look at this example program. We've got a macro with output to string that uses parameterize and get output string and all that good stuff. And then we have two occurrences of with output to string. We've got an occurrence of 4 in the body. This macro, when it rewrites these two expressions, will generate 2 occurrences of parameterize. Okay, so that's 2 occurrences of with output to string, 2 occurrences of parameterize, 1 occurrence of 4, and then all the application and data and all that, little hook macros. Those are there too. Okay. Let's see. So the parent of a macro occurrence is the occurrence that produced that expression or definition or whatever. So each parameterized occurrence has a parent, which is a with output to string occurrence. Okay. If it doesn't have a parent, then I'll call it a surface occurrence. So 4 is a surface occurrence. With output to string is a surface occurrence. The direct cost of a macro occurrence is just the difference between the output size and the input size. Asterisk. Local expand messes everything up, but I'm not going to talk about it. Okay. So the cost of the direct cost of with output to string, well, take the size of this term, take the size of this term, and subtract. The indirect cost also includes all of the child occurrences. So this use of parameterize, since it's produced by with output to string, kind of that cost also gets charged to with output to string. The cost of the parameterized expansion. And this means that you can't have your macro appear to be low cost by just expanding into another macro that does all the work. You're responsible for every macro expansion that you cause, but not the expansions of things that are in your arguments. And, oh, this is convenient. This corresponds pretty much exactly in most cases to what hygiene is already tracking for us. So that's what the macro profiler does. So you can mess it up by doing weird things that are not hygienic. So don't do that. Okay. And of course you have the normal kind of, which one is better? Well, you kind of need both of them, I think. So the indirect cost shows you what's actually contributing to the final program size. And the direct cost shows you concentrated opportunities for improvement. And you can't really do without either one of them. Okay, so here's the FI example again. And you notice define struct, so total means indirect, total over all the occurrences of defined C struct in that module, of which there are 8. And the total cost is pretty close to the direct cost. So it looks like if we want to make this expansion smaller, we're going to be doing work in the find C struct itself. Whereas for arrow star, the direct cost, the total direct cost, is still somewhat large, but not quite at the same magnitude as the total indirect cost. And this is why, say, Aerostar has a difficult job, because it needs to do, it needs to make a proxy that is, doesn't add ridiculous reflective or dynamic overheads, which means that you kind of want to specialize that to particular, in this case, keyword arguments. And that's why Lambda shows up here too. Lambda is doing a lot of work to implement, direct keyword argument. Dispatch, I guess, calling convention. So fixing this would be a little bit trickier. We have some data. We have a rough idea about how to analyze it to find costly things. What is the fix? There's only one that I know of, and it's use helper functions. So it's supposed to stand up and take a bow. Okay, so use runtime helper functions. For example, here's without the string again. You don't need to put the parameterize in the body of the macro. You can just make a little helper function that does the work and thunk your expressions. So this is just anti-inlining. Right. And likewise, macro generating macros are kind of a cool. This is like it's one of those blow your mind moments in Racket metaprogramming, but it's not always a good idea. So here's a little cartoon version of define FFI definer. It generates a macro called defineX, and that takes some arguments and actually makes a definition. And this works, but you have to learn about ellipsis escaping, or how do I make sure that this ellipsis is interpreted now and this one's interpreted later. But what I usually recommend is make a compile time helper function that creates a transformer and then just define syntax define X, make that transformer with these three variables. So just use helper functions. Here's what they look like for macros. Okay. So I'm a research scientist at the Czech Technical University in Prague, and I'm hanging out with a whole bunch of empiricists nowadays, and they have data. It makes me think I should have data too. So I want data, and this is the logo for the university, and I love this. It's the Czech lion with, I don't know if this is a compass or calipers.
Dividers, probably.
What's that?
Dividers for better.
So data. data goes here. Yeah. Okay. So I went and applied the macro profiler to the main distribution. And I found about 29,000 distinct macros. Those are the ones that actually got used. There are about 800,000 macro occurrences. Oh, 8 million. Oh, yeah, that's better. Oh, yeah. And about 1 million of those are actually surface occurrences. And here is the distribution of occurrences. The x-axis is macros, and this is not, a line graph. This is a histogram. So the leftmost third of a pixel or so is the most popular macro, and it's that popular. And let me point out, this is on a log scale already. This is what the distribution of macro popularity looks like. What's that? No. I'll come back to that. And here's what the distribution of surface macros looks like. There's a red line beneath the blue one, counting only the surface occurrences. So what do you think? Just take a minute. What do you think are the most popular 2, 3, 5 macros in the main distribution? Okay. Take a second, think about it, make bets with the person next to you. Okay. So let's go to the data. Yep.
Bananas.
All right. So who said application? Application is number 1. Number 2 is let. Number 3, they're all other ones, is and. Number 4 is do wrapping module begin. I'm sure everyone is excited about it. And then define, and new define, and syntax, and so on and so forth. So here's a nice data, and we can try to figure out where the filter thing. Oh, here we go. So we can. So what contributes most to the compiled size of Racket? Well, syntax case star star. And if you go down a little bit, there's our friend arrow star. You start hitting syntax bars around here. So let's go to the data. And then just for your entertainment, here are some plots of the popular macros, output size versus input size. And here's application, and it's linear. And here's and it's linear. And here are the top 6, and they're linear. And really, this is not a good measure, right? Because the input size and the output size are going to be dominated by the size of the sub-expressions that the macro doesn't care about, right? Okay, so let's remove, oh, well, some of them are interesting. That's syntax case star star, and that's syntax over there. And then require is just wild. But we get more interesting pictures if we remove the common nodes from the count. So we'll look at basically structure consumed, structure produced versus structure consumed. And here's application. And now we can start to see it's, bimodal, I guess. I'm going to say these are probably the keyword applications, and these are the ordinary applications. Right? And most of them are applications of a function of one argument. Here's syntax, which is still kind of, it makes me think of a flower, or a bouquet. Here's new define, and again, you see separation. These are probably keywords. These are ordinary defines. These are maybe the function shorthand. I don't know. I haven't checked it. Lambda, again, ordinary keywords. Turns out new lambda and new lambda are different macros. Similar. Quasi-quote is a little bit more scattered. Syntax parameterize is interesting. Has a little staircase there. And then con, I don't know if you can see this, but it has, strata that are probably like these. The strata are probably similar shapes, and then as you recur, con is a recursive macro, so you're regressing here and you gather more instances as you go along. And 4-fold x derived. And then here is arrow star, and you see the same kind of.
Right, in the 4-fold x derived, do all 4 loops?
I think so. The thing that I'm wondering about here is whether they do any local expansion. I think not, because I dropped those from the produce consume graph. So the cases that Robbie has already optimized are down here, and the cases where it has to just generate the code for a new proxy to make it fast and not do apply and things like that are up here. So that's the end of the story. Doesn't really have a conclusion. I'm not sure how to get it. There we go. Thank you.
all want to ask about your particular macro, what Ryan's system says. We can have one question about the general stuff before as Chris is working.
So there's a tension between using helper functions and generating specialized code. With a thought on how to resolve that tension.
Use the macro profiler and use helper functions when you think your macros are too big. Yeah, I don't want to say you have to do this to every macro that you write. Right? That's going to be a headache and take time out of it. But this is how, when you've got macros that are inlining too much, is how you find out and how you remedy that.
All right, so our next speaker will be Chris, who is a professor at the University of Denver. He's presenting some work that's with Jeff Eddington, who's over here, who will, you can ask about later, but won't be presenting. So take it away.
There we go. Hello, everybody. I'm Chris Kowatadiki, and today I'm going to be talking about a language called Design by Numbers. And this is work, just something that myself and my colleague Jeff Edgington, who's in the audience over there looking, put together. And so before we get started, if you want to follow along, you can go to the Racket package manager and download Design by Numbers and install it, and then you can follow along with some examples to see what's going on. So just a little quick introduction on who we are. We're just the DUPL group, where a group is defined by anything two more people with the same interests. We're also associated with COSA, which is the Clinic for Open Source Arts, and that's a collaboration at the University of Denver between arts and computer science and trying to create open source tools and things for artists. And generally, we just like the interaction of programming languages and education and art and various other things like that. So why are we here? Jeff talked me into doing this, so that's why we're here. That's Jeff. He looks innocent, but watch out. He makes a few talks and stuff. And so we were interested in implementing an imperative language and seeing what this older language called Design by Numbers was, and understanding, like what the complexities were when you put this on top of Racket, because it's not the typical, S expression kind of language. And so, before, last summer they had a nice thing on Racket's summer school about building languages, and so we started this actually before that. And so it would have been nice. We've been there. Jeff ended up going there, and so after we had done a lot of this stuff. So you should go to the Racket summer schools. They're cool. And so we're also here because we want to talk about language design and how it affects users. In addition, we really want to understand Racket's macro system. I'm fairly new to Racket, probably compared to some of you, and so it seemed like a great idea to, if you're going to do this, the way you do it is by building a language. And we didn't really build a language, to be honest. We more like implemented one, and it is this from this book, Design by Numbers. And this is an older book by John Maeda. He was a designer and artist and was interested in teaching like artists how to program. And so you'll see that there's lots of little pictures in here and an explanation of what happens and the kinds of things you can do with Design by Numbers. And so we wanted to implement that. And we also work a lot with our artist colleagues, and they were pretty excited. In case you don't know the history, Design by Numbers eventually became, well, his students, John Maeder's students, became processing. And so that's used pretty widely, but that was really where sort of the original ideas came from. It turns out that just looking at the surface syntax, there's not a lot of, there's a Java, really old Java version of this, which sometimes works, which is why we wanted to recreate it. And just looking at the surface syntax wasn't really quite enough. And so we had to sort of pretend like we were language archaeologists and understand like what the language meant and what was going on. in terms of the programs themselves. And so we ran examples and we got the wrong results. We learned a lot of things about doing that. So just a couple of caveats. Obviously, this is a work in progress. Don't blame us for the syntax. We didn't design this. Okay, we're just the implementers. And there's more to come. You know, like I said, I'm kind of new, so we set up the package system and the tests, you know, they're not connected right or something. So just bear with us if you download it. So what is designed by numbers? Let's just look at some examples. So it's an imperative language. So you have something like set x5, and this is going to set the statement to this sets the variable x to 5. You have curly braces. So when you declare something like a procedure, command is the name that you use to declare that. Foo is the name of the procedure. X is the argument that it takes, and so on. And so you can define these. You can define functions that return values. And it also is a language that has primitives to draw pictures. So for example, line 0, 0, 30, 30 draws from coordinate 0, 0 to 30, 30. And we should note that the language is really built by somebody who's steeped in design. And so that's why the things that you're going to see here aren't going to be what you expect. Okay, it's not created by a language designer like someone who loves lambda calculus and parentheses. And so really, like I said, an artist designer. It's also really a language that was built to teach artists. And so really you wanted somebody you know, that could go from being an artist to be able to create digital art. Okay, and you know, hopefully you're thinking that those are trees and not giraffes. Little joke from strangely. Okay, so you know, in some respects, Bob Ross is kind of right here. You're hoping that people are going to experiment with the language, and their mistakes are going to be creative. Okay, and so like I said, you know, design by numbers has its own nomenclature that's specific to the visual art. So you'll see some language that's familiar to artists. So when we're building something that's going to be the screen, we don't say like, oh, draw a screen with a frame or whatever. We call it paper because that's sort of what the medium is supposed to simulate. We have color also, and color. Oops, color is all the color in design by numbers is grayscale. And it's represented by a number from 0 to 100, not 0 to 255. 0 meaning there's no ink being applied, and 100 meaning 100% of the ink is being transferred to the paper in essence. And so these look different than what you might expect. And so then we also have things like lines. This is just the language that you might learn when you're creating something or being, you know, taking art classes or whatever. Also, it has some interesting and unusual features. So for example, time plays a big component. Now, obviously, every language has the ability to, you know, access a time library. But this is a keyword, and it lets you get seconds or hours or milliseconds. And it's important when you're an artist to understand how time affects things. That's a big part of it. The other thing that's kind of interesting is they have this connection to a network server. And so this is not so that they can build web applications. This is a server that would run, and everybody who was using design by numbers, when they wrote code like this at 384, it would go to location 384 on whatever the network server was and get some information about the color that was located there. Okay, and I want to be clear, this is every single program in the world connects to the same server, and they all have the same, they have 1,000 locations that they can write to or read from or do various things. If you think about what they're trying to do, is they're trying to use the network and this interaction between programs is a sort of a creative input, right? So they could take whatever data was there and write stuff and read stuff. So it's kind of interesting, the sorts of things that happen there. And so I'm going to show you some examples really quick here. Let me just do a little switcheroo so you can just get an idea. Okay, so this is what a design by numbers program looks like. And what you can see is it's a hash lang, but lang DDN at the top, and then the most simple sort of hello world program is paper 0. And in that you get this beautiful 100 by 100 piece of paper, and that's all it was limited to originally. Later on, they added some features where they had a color and you could do bigger paper. But in the book, this is how they're limited. And it's kind of interesting because there's, when you're learning to program and when you're an artist, one of the things you learn is something about constraints. And so this is a constraint to tell you to be creative, and there's this small space. You don't have a giant, HD 4K display or whatever to draw. So we can then just, we can modify this and do things. So we can set the color of the pen that we're going to write. So we can say like pen 100, and then we can draw things. So we can say like line 00, 100, 100, and ta-da, you get a little black line that shoots across the screen. You can then, if you want to ask, you can ask questions like, is something smaller than something else? Well, let me actually go to procedures first. So if we wanted to define a function, we would say like command, and let's say we wanted to define something for horizontal line, and we want to say what coordinate it's going to draw at, and I don't have indentation working right, sorry about that. And then we would say like line 0y 100y, and then when we run this, we can then execute. I should put a pen color in here. This. So then I can say like horizontal line 50, for example, and I can draw a horizontal line at 50 or a horizontal line at 20. And so you can create commands. Now you notice that there's curly braces, and we do have an idea of setting values. So I can, for example, say set x 25. Or not, just ignore that. So I can set values, and then I can use them later on in my procedures. And so set x 25, and I put that here. And so the idea is, of course, that so you say setting that we can then draw things and. So then we can draw things with our commands. In addition, we have the equivalent of like greater than or less than. These look different than what you would expect. So if I were writing code, I could say like smaller or y 20. So I could say this, and then I could say like set color to 5. Right, and so all of our if expressions then become this idea that I'm asking, is something smaller than something else, or something the same as something else, or not the same? So the syntax is just very simple. We have this nesting. One of the issues that comes up with these braces is that if you give this to a regular programmer, they're going to think that the braces are scope. And the braces, there is scope, but it's either global or it's at the function level. And the reason is because if you look, like I can set this color value here, it has to be able to be seen by later code. So I need to be able to use that variable somewhere else. So the braces don't indicate scope, which meant that we had to do some rewriting stuff. So that's just a quick example. Let me get back to just talking about how we did this and put this in. Okay, so how long will it take to all this? Well, really the first commit for this was September 30th, 2016, which turns out it was a long time ago. And that was our first commit, which you can't read very well. But it was, Jeff had gone through this book and he said, well, what's the syntax? Let's figure out what the syntax is. And so we wrote it and submitted it as a JPEG. That was a long time ago. And then we wrote the parser and Lex really quickly. We were really excited about it. And then we wrote the interpreter. And of course, that's when we realized there would be some issues because as soon as you're trying to do an interactive graphics program and have like loops and things like that, then your window is no longer going to get events because Racket's single threaded. So we had to start dealing with that sort of thing. And so it was easy to create the pen, the paper, and the color. We used Racket GUI code. Of course, we're going to use Universe, but then mixing the imperative stuff with that was kind of a mess. The real trick was that we had to create a new event space for our GUI because this allows it to sort of receive these events while you have your loops going on. And then we would sprinkle in refreshing of the screen periodically in the code when we did the macro expansion. The easy way, at this point, this was maybe like a month after we started, we wrote the interpreter. Everything was really great. And then we could use it in classes, so we could say, oh, here's how you write an interpreter with an environment passing style. And to create the first hash line was really easy because the reader just called parse, created an AST, and then the expander just expanded into interp, new environment AST. Now, that's obviously not the right way to do it, but it's an easy way to do it. Okay, so that was great. And then we paused. And then finally we got back to it. We started thinking about like, okay, we're gonna do this right and go back and look at the macro things and see like, how do we expand this properly? And so we needed to do some AST manipulations because of this sort of thing to fix scoping. And in order to do that, we wanted to keep our AST. So we used structs because I like structs, and the lists, you know, they get messy really fast. So we use structs, and then we would expand that. We could rewrite them to sort of lift all of these declarations, because as you can see, this has to be this might at the first time it's used become a create var sim. And so really what we need to do is create the variable first, and then do sets later on whenever they call set. Okay. So we would do rewriting to do that sort of thing, and then we could just take our AST, turn it into an S expression, pass it to the macro expander, and at that point, expanding things with the macro system was really easy, pretty straightforward when you do that, and so you get code like this. The real issue, the main issue that we ran into, which was a small surprise, was of course value is the return statement in a function. And so you can call that anywhere. And so, of course, in order to deal with that, we use syntax, define syntax parameter to say, like, here's the value command. And then we can do call EC and then parameterize this and make sure that value is only called in the right sort of places. Another small surprise that was nice was that we needed to be able to load files. And so all we had to do was turn this into require, and then macro Racket handled it wonderfully. So that was really great. And so what we got out of this is that we did learn something about how art and design relates to programming languages, and are now looking at version 2, talking to our artists, colleagues, friends, and friends to understand like what's a nice design that doesn't have some of the weirdness of design language. Okay. Just a final quote before I go. John May wrote something about his book, which is kind of funny. He basically said, like, the actual point of the book was to get more non-programmers to program as a means to hopefully realize how boring programming can be. But I think what he was trying to say really is that if you look at like, in the book, he has like lots of statements, and he says you should replace this with a loop, like to sort of understand some of that. But then the other part was what sort of made sense, which was, and then to reimagine what programming should be. And so that is actually nice. All right, thank you.
Any questions during the transition time?
I have colleagues who love processing and are keep motivated by things like this. The number one thing that I would need in order to sell this would be, I think you know what I'm going to say, documentation, a beautiful documentation page like the ones that Robbie has for how to design for it. You open it up, you page down, you're like, yes, look at these beautiful things, I want to try them all.
Yeah, that's an excellent idea. And you know, we have the Racket documentation that we're putting together, and so, but yeah, having something really great would be fantastic, especially for non-artists.
So where's that great? Just get something.
Yeah, something useful. Yes.
So when you were dealing with designing the language firsthand, I mean, have some artists push back to the idea of being imperative in the first place? Have some of them wanted to take more of a declarative approach, or maybe a rule-based approach, where they didn't have to think in terms of sequences?
Yeah, I don't know that the artists, people that we've talked to, they don't seem to think about it like that in any terms. They think about like being able to do cool things like colors and write. They understand that, you know, functions and things like that. But we have been, you know, Jeff and I have just been talking about what does it look like if it were a more functional style, and how would that affect it? You know, how could you represent pixels with functions and various interesting things? More creative stuff, then I think they're somewhat limited, because these languages like processing and stuff are somewhat limited in their style to what then the programmers can do. And we'd ultimately like the tools to be modifiable by the programmers. And by the artists themselves, so that they can expand the language the way they want. And so that's where the macro system helps and make it more, you know, their tools.
All right, great. Next up, we'll be hearing from Jesse Alamo. So Jesse, he works at a web e-commerce company, but many of you may be familiar with his book that he recently published on programming web applications in Racket. But he's going to be talking about something totally different and new projects. So let's welcome Jesse.
Thank you very much. It's my pleasure to be here. It's my first time at RacketCon, first time to be able to meet. You may know me from my work on web programming in Racket. In fact, that's my day job, and I really love working on the web. But what happened is that there was a really cool paper that came out this winter or spring. You don't know what we're talking about, right? The communications VCM paper. And that was a really fantastic watershed moment. This paper that was published, it was a long time in writing and editing. And I thought, okay, I'm going to try to dig into language-oriented programming. Switch topics a little bit from just web programming to try to dig into a little bit more of the philosophical side of what's going on with Racket, or what makes Racket special. Now, to put this a bit crudely, my thought was, well, what is a family-friendly place, right? I don't want to say it. What is language-oriented programming? I love the paper, I read the paper, and I thought, okay, I kind of sort of know what that is. I've been doing this for a long time. I had the pleasure of being introduced to Scheme at a very young age. And I was able to then switch to Common Lisp. I got a job in Western right after college, and I was working there in Common Lisp. I worked in Common Lisp for many years. So I know all about macros, def macro. Don't hit me. So I kind of sort of know what this is all about. I've been playing with Racket for a few years. I mean, we all have some intuition. I know that there are canonical resources, like the paper that came out this spring, the Racket Manifesto, the papers that are written by Matthias and some of the other core Racket guys. I know about these things, but I wasn't satisfied with that. And so I couldn't just do self-introspection. I wasn't satisfied with looking only at the canonical resources. So I thought, why don't I go out to the community and find out what is going on with language-oriented programming? I want to go beyond what I have. How does the idea of language-oriented programming play out among kids? So what I did is I sent out a survey to a bunch of people. Many of the people in this room, I think, probably received my survey. And many people responded on oral. I probably came out of the blue for a lot of people. I'm not a big figure in the community I'm in. I rarely contribute to the mailing list. The problem with living in Europe is that a lot of discussions are finished by the time I wake up. And so I don't have anything to say. The issues suck. That's one of the issues. So perhaps you can take a look at some of the questions that I had in mind. Maybe for a little bit of context, I'm interested in promoting Racket. I'm interested in getting newcomers to come to the language. I'm not interested necessarily in finding out what a seasoned professional thinks about how to get seasoned professionals to come to Racket. That's not necessarily what I'm working on. I'm interested in getting more people to come to Racket, people who have no idea what language-oriented programming is. Right, so that's what my questions and my survey questions are aiming at. So the idea was, I mean, I know about these resources, the canonical resources, talk about examples, but I wanted more. I felt like I didn't have enough. I want lots and lots of examples so I can really dig in and get a lot of meat here. So I asked people, I said, can you please give me an example or two of your own that best exemplifies what you think language-oriented programming is? Yeah, don't just tell me, well, look at the paper. I want you to say what language-oriented programming means to you. And there was an issue that came up very early in this survey, where initially they focused on people in the official PLT group as it's officially listed on the homepage, which turned out to be a rather somewhat out-of-date list, and certainly doesn't include all of the Racket community today. By the way, maybe we should update that list. One of the suggestions I got, I believe, from Jay and also from Black, was to expand the discussion and talk about those who use Racket for teaching as well. So not just the hackers or something like that, but the teachers too. So I also included them. Potential survey respondents. And then I wanted to know about motivation. What motivates you to make languages? Why don't you just make functions, right? However you want to do things. That was one of my serious questions. Then I thought, okay, I wanted to give people a chance to promote their own work, but I also would like to see what people themselves look like in the work of others. So I said, what is an example or two of language-oriented programming in the work of others that you find necessarily impactful? I wanted to, again, keeping in mind that my perspective was newcomers to Racket, people who are new to Racket, didn't even need to listen at all. And I wanted to find out from seasoned Racketeers, if they've had any aha moments, something that really clicked for them, that helped them to really get rolling on the train tracks of Racket. I wanted to find out if there are any books or courses or tutorials or whatever that helped other people to get more on board. And then there are a couple of questions I asked about pain that goes into this. Because again, if you think about newcomers, they're interested, they're motivated to learn the stuff, but they're going to run against a bunch of walls that are perhaps long gone for us. Yeah. It's important, I think, to try to document these as well as possible. What are the things that really be used? What are the things that hinder you? I asked people also to think about the technicalities that go into making languages in Racket. Think about the idea of phase separation, evaluation, semantics. A lot of programmers are interested in Racket, but they may not know about these things. Keep in mind that not everyone goes through a 4-year or longer university course who might come to Racket, so they actually not know about some of the ideas that are taken for granted by Racket. I wanted, again, to talk about promoting Racket, and I asked people to tell me, what difficulties have you had in talking to others about Racket, or how you make languages? Do you find that there are sticking points that or have you overcome them, and so forth? The final question, I had 9 questions, was to get people to think about when making languages is definitely not the right thing to do. I think one of the things that can happen if people go into Racket, they might perhaps go a bit overboard. They might think, well, if I endorse this, I need to somehow see everything as a language, or make everything as a language, right? It's, I want to try to put the brakes on this idea, or find about what other people think about that. What are the limits of this? Clearly, there's some kind of heavy engineering, so how can we put the brakes on that? That's the survey. So it's a 9-question survey. Again, with the emphasis on promoting Racket, attracting newcomers. I surveyed people initially by looking through the official DLT list available on the webpage, but that eventually got expanded. I started looking at people who had participated in a previous RacketCon. That's really into Racket if you're participating in RacketCon, and the chances are very good that you're doing something with language. And so forth. So I managed to interview or send emails to more than 80 people, and I got about 30 responses. And I made an ebook out of it, which weighs in at 315 pages. This thing is fantastic. I've got a ton of things to say. Unfortunately, not very much time, but I'll try to give you a bit of a summary. As you might imagine, there are different programmers out there. Not everyone sees Racket the same way. Not everyone's playing at the same level. Not everyone is trying to solve the same problems. So I tried to divide up people into groups. And I'm sure I picked somewhat tongue-in-cheek names here. I mean, no offense by any of these names whatsoever. But there are those groups who are enthusiastic embracers of language. These are the people who are on board with language-oriented programming, whatever that means. They use it to solve lots of problems. They're happy to make languages frequently, and they're happy to talk about Racket and others and promote this idea. These are awesome people. We should be very thankful that there are people like that out there. We've got the jaded professional. The jaded professional is someone who's been doing this for quite some time, not necessarily Racket, but probably Racket. They've been down the road of telling people to make languages and not succeed, They know how making languages can be difficult. They know when making languages is hard and definitely inappropriate. These are guys who learn a lot from. There's the fellow travelers. Racket is interesting because, as we see, so Racket kind of blends in a little bit with the scheme world, of course. There's also some people who are looking at Racket from the outside, perhaps more than you might think, from, say, the closure community and the common list community. Fellow travelers are people who perhaps play with Rackets. It might even be their main thing. But they're definitely interested in what Racket has to contribute, and they're just waiting for a chance to jump in for deeper. Mere users of language or the program. I put the mere in quotes, and that's not at all intended to be some kind of downplay. Mere users, but how I understand that is people who actually don't make langs. They use a lot of Racket. They use Racket as an awesome list of scheme, yeah, and they do some kind of language-like activity there without going all the way up to making langs. But would like to be, as I deliberately chose not to use the word one. Wannabe has a very negative connotation. Would like to beers, but I understand by that people who want to jump in, they just don't know how, or they find it too difficult. Even though they use Racket a lot, they still find it too difficult. They're not sure if the problems that they're working on really justify or overwhelm their use. Another aspect that I found especially fascinating by doing the survey was seeing how there are a couple of different aspects of language-oriented programming. There's language-oriented programming outside of Racket and inside of Racket. One of the things that I myself didn't appreciate, I'm relatively new to the language. I've been playing it for about 3 years now. But even in that time period, it never really occurred to me, or I never really dug into the idea that you can look at Racket itself as a large-scale example of language-oriented programming. It's a family of many languages playing together. In fact, one of the survey respondents called this one of the most persuasive examples of language-oriented programming. Racket itself. Instruction of Racket. Making a lang is clearly what could be meant by language-oriented programming. Using a meta-language, it's kind of like making a lang. I'll give you guys a little bit of help. A pass expression language. So reader hacking or adding your notation could also be an instantiation of language-oriented programming. You might also consider language-oriented programming to be kind of normal Racket, just with some macros added on, where you kind of build up kind of language for your problem in that way, without yet being a full language. Or you could be an interpreter that just evaluates S expressions, just kind of similar to this S expression thing I had here. I love this example where the evaluator was just interpret data. Nothing wrong with that. What's interesting is that language-oriented programming also exists outside Racket. There are some people who are doing things that are similar to language-oriented programming or overlap with it in some ways conceptually. What I found interesting is this paper from quite a long time ago, maybe by Martin Ward, who takes on the idea of DSLs, but from a very different angle. It's coming at it from the software engineering. There's the Spooffax guys and what they're doing that overlaps, at least conceptually, with language-oriented programming. There's this interesting tool made by the guys in the Czech Republic, JetBrains. MPS is stand for Meta Programming System. They also have their own spin or take on language-oriented programming. There's also other lists and non-lists that have macros or macro-like features, like Sweet.js. I learned about that in surveys. Rust apparently has macros. I actually didn't know that. And also, you can see that certainly Lisp, but definitely not Racket, is not the only one who came up with the idea of DSLs or embedded DSLs. You see this also in Haskell and in JavaScript and so forth. And in fact, given the intense amount of energy that is put into JavaScript, it's perhaps no surprise that there's a considerable amount of language-oriented programming type work going on there. Although there are no macros. Ouch. So we're about the Racket community here, yeah? What kinds of problems do we face? That was one of the aspects of the survey that what difficulties do you see? How can you overcome them? One of the common things that I heard from a number of people was that although Racket it smooths the path for making a language, the API, as it were, is sometimes a bit rough and it's maybe not so easy. Perhaps not so memorable. I had some people say that they made a language, then they forgot about it for a while, and then they wanted to make another language, and they actually forgot how because it's evangelism. Promoting Racket is hard. I've heard that from a number of people. Perhaps that's your experience too. I myself try to promote Racket as much as I can, but it's not always an easy thing. One of the things has to do with those annoying perennial parentheses, which to my surprise, I found that even some seasoned Racketeers and seasoned list programmers don't actually like those expressions. They kind of see it as a necessary evil. Yeah. I myself actually don't mind. I guess that's one of the things, if you come up to list very early in your life, you might actually see it as a problem. I mean, I play this. Other people try to avoid as much lexing and parsing as possible, completely skipping that. Other people try to meet their users in the middle by offering some kind of non-S expression syntax. And I have found, by the way, and this is perhaps your experience as well, if you're selling Racket to others, maybe having a non-S expression syntax for the languages actually can increase the chance of success. Recurring themes. A lot of people talked about their inspiration and whatnot. Beautiful Racket by Matthew Butter. It's a real shame that he's not here. Was cited by a lot of people as a really incredibly valuable resource for getting into language programming Racket. So we should be very thankful for what Matthew is doing. The Racket Summer School is also cited by a number of people. So I guess that's your chance. It's a very good chance to learn about language programming. You learn from the horse's mouth, as they say. Teaching languages. A number of people are blown away by the idea of teaching languages. Some of the people who respond to me use teaching languages. Others use them, but they like the idea of teaching languages. They find it really interesting. The idea that Racket being an exemplar of language programming came up many times. The idea that when you write lang Racket, you're already using a whole stack of languages. I'll just tell you about the stars of the show here, flash some of these. This is an ongoing project. The final star might be you, because you're welcome to contact me, and I'm happy to add you to the list. Thanks for your time.
Any questions for Jesse?
Would you be able to point out a single tool or resource that would fill the biggest gap in what people say are the resources now, or the resources that could be?
I think based on what people have said, Beautiful Racket is that definitely covers a lot of bases.
What's missing now that of the resources that could be expected?
Of the resources that are missing, probably it would be helpful if there were more blogs out there that talk about Racket, more documentation about projects and so forth. I think I've overheard many people talk about this as a gap.
All right, we'll now head over to lunch. So lunch is at Landry's. So we are basically right there, and it's just around the corner. But before that, we're going to take a picture because, as was mentioned on Wednesday, Racket received the ACM SIG Plan Program Languages Award. And at that event, some of the Racket organizers stood up people recognize, but we feel that this award is really to the entire Racket community, and that is represented by you all, so we want to have a celebratory photo of that. If anyone has a really nice camera that they'd like to take, that'd be great. Otherwise, we'll just use a lame, cell phone picture. No. And so what we'll do is we'll go out into the sort of the main lobby area and then go downstairs where it's nice, where there's that like shiny floor, and then someone will stand up there and take a picture of it. So that you can sort of orderly go over there, and then from there it's a natural walk over to the
There's some boxes on the floor. They pass the boxes.
Yeah.
Do we bring backpacks with us? Or?
Yeah, this room will be open, so don't leave things in here that you don't want me to take.
I'm not.
But also, like, it was focused before, but then the light.
I've got your backpack and stuff.
I don't really know what. Yeah, like, I don't think there's anything on here. It does not look like it. I don't think there's like. Okay, now that's better.
It's never had like good light.
Yeah.
It doesn't capture the screen.
Yeah, no. Hey.
Cool. We're done. You
Okay.
can just stop it.
Okay. We might want to consider using.
Actually, so it doesn't.